Welcome to the deep dive.
Great to be here.
So today we're diving into a really interesting article I saw on VentureBeat.
Oh, yeah. Which one?
It's by Matt Marshall, published just a few days ago, April 25th, 2025. And the title kind of says it all. The new AI calculus, Google's 80% cost edge versus OpenAI's ecosystem.
Okay, yeah, that title definitely jumps out. It's hitting on something we don't always focus on, right? Everyone's wowed by the model performance, the new features.
Exactly. But this is about the nuts and bolts, the actual cost of running these things. And it suggests Google might have a serious leg up.
It's crucial stuff because, at the end of the day, especially for businesses adopting this tech, cost is a massive factor.
Yeah.
Maybe the deciding factor sometimes.
Right. So that's our goal today, really, to unpack what the article is saying about this potential quite significant cost advantage Google seems to have over OpenAI in the generative AI space.
And it's not just like tech company gossip.
Yeah.
This really affects how AI is going to roll out, how accessible it becomes.
Yeah, for you listening, understanding these economics helps make sense of pricing, maybe future trends, why certain platforms might push certain deals. It's fundamental.
So the article kicks off by pointing straight at the compute economics. That seems to be the core of it.
And specifically, Google's long game with their own custom chips, right? The TPUs.
Exactly. Tensor processing units. They've been at this for, what, over a decade? Building their own silicon.
The latest generation mentioned is Ironwood. And the key point the article makes is that these chips are tailor-made for AI workloads, both training the models and then actually running them, serving the inferences.
Which inherently makes them more efficient for those specific tasks. It's like having a custom-built tool versus a general-purpose one.
Okay, so that's Google's side. How does OpenAI compare, according to the piece?
Well, OpenAI, largely through their partnership with Microsoft Azure, relies heavily on Nvidia GPUs, the H100s, the A100s.
Which are, the industry standard, incredibly powerful chips, no question.
Absolutely powerful. But the article brings up this concept of the Nvidia tax.
Okay, the Nvidia tax. Let's dig into that. What does that mean in this context?
It basically means that because Nvidia has such a dominant position in the market for these high-end AI chips right now.
They can charge a premium.
Precisely. The article cites analyst estimates suggesting Nvidia's gross margins on these data center GPUs are, incredibly high, around 80%.
80% margins, wow.
Yeah. So if you're OpenAI or anyone else buying these chips at scale, you're paying that premium. You're paying the Nvidia tax. Google, by making its own TPUs, effectively bypasses a lot of that.
Okay, so this is where the numbers get really interesting. The article tries to quantify this difference.
Right. It puts forward estimates that Google, with its TPUs, might be achieving its AI compute power at something like 20% of the cost compared to using those top-end NVIDIA GPUs.
20%. So basically an 80% cost edge for Google, just like the title says. Or looking at it the other way, maybe a 4x to 6x efficiency advantage per unit of compute.
That's the potential scale of it, according to these analyst estimates mentioned in the article. It's a huge difference in the underlying cost structure.
And this isn't just some abstract number, is it? The article connects it to something concrete.
Yeah, exactly. API pricing, which is what users actually pay.
So how do they compare there?
Well, at the time the article was written, it found that OpenAI's O3 model, which I assume is their latest or comparable high-end model, was roughly 8 times more expensive for input tokens.
8 times for the input.
Oh, and 4 times more expensive for output tokens compared to Google's Gemini 2.5 Pro. And tokens, just quickly, are like the pieces of words the models process.
So a developer building an application, maybe processing lots of text in and generating lots of text out, that price difference could be enormous.
Absolutely massive.
Yeah.
It directly impacts the viability and scaling costs of applications built on top of these platforms.
So thinking strategically then, what does this mean for Google?
Well, the big implication is total cost of ownership, or TCO. For enterprises looking to deploy AI long-term, predictability and lower overall cost are huge selling points.
Right. It's not just the upfront cost, but what it costs to run month after month, year after year.
Exactly. And if Google can genuinely offer that compute at a significantly lower cost base thanks to their TPUs, they can potentially offer much more attractive, stable, long-term pricing. That's a big deal for businesses making strategic bets on AI.
And the flip side for OpenAI, the article mentioned their costs.
Yeah, it highlighted some pretty staggering projections, like OpenAI's compute costs for 2025 could potentially make up over 80% of their total operating expenses.
Wow, 80% just on compute. That's unsustainable almost.
It certainly puts immense pressure on their business model, which is why, as the article suggests, it makes sense that OpenAI might be looking into developing its own custom silicon down the line. They almost have to control those
It
costs.
seems like a necessary move if those projections hold true.
Definitely something to watch. So the core takeaway here really is this potentially game-changing cost advantage Google seems to have built through its long-term focused investment in TPUs.
And we see that advantage reflected not just in theory, but in the actual API pricing that developers face today.
Precisely. It sets up a really interesting dynamic in the market purely on the economic front.
Now, the article, it did briefly mention other factors too, right? It wasn't only about cost.
True. It touched on things like agent frameworks, the actual capabilities of the models themselves, how well they fit into enterprise systems, the whole ecosystem picture.
But it feels like the cost piece is presented as this foundational element that could influence everything else.
I think that's fair. Like, how much can you invest in experimental agent frameworks if your core compute costs are sky high? Cost efficiency potentially frees up resources and enables different strategic choices.
Yeah, you could maybe offer more generous free tiers or target different kinds of applications that are more cost sensitive.
Or just be more aggressive on enterprise pricing. There are definitely layers beyond just the cost we could get into another time
Right.
about model performance nuances, data privacy aspects, platform integrations.
For sure. But for today, the spotlight from this VentureBeat piece is really on that stark cost difference driven by hardware strategy.
Absolutely. And just a quick note for everyone listening, our next deep dive will be out on Friday evening.
Great. So, as we wrap this up, thinking about this huge potential cost edge for Google, I want to leave you with this thought. How might this fundamental economic difference really shape the future?
Yeah, it's not just about which company wins.
Right. It's about what kinds of AI applications even become possible or practical on a large scale. If one major player can offer the underlying engine at a fraction of the cost, what new innovations does that unlock? What kinds of tools might we see that just wouldn't be economically feasible otherwise?
That's the really fascinating question, isn't it? What becomes possible when the cost barrier lowers significantly? Definitely something to mull over.